Okay guys, so today we're going to solve the problem largest subtree sum. So the problem says you have been given a binary tree of integers and you're supposed to return the largest subtree sum in the given binary tree. The subtree of a node is defined as the sum of all the node values formed by the subtree rooted at that node. Okay, so before we start, I'm just going to tell you this, that I couldn't find the problem anywhere in Geeks For Geeks or Lead Coach. That's why I'm solving it on Coding Ninjas right now. And yeah, okay, so what the problem is we need to find the largest subtree. Okay, so here 1 minus 2 4 7 3 minus 9 2, this whole tree is in itself a subtree. Okay, and we could also say minus 2 4 7 is one subtree, 3 minus 9 2 is one subtree, 4 on its own is one subtree. Okay, and we need to find the subtree which gives us the largest value. So, and we need to return the sum of it. So basically over here, as we see in this question, so 4 minus 2 and 7, if you add them up, would give you 9, which is greater than any value in all these subtrees. Okay, so if you take any subtree in this question, such as minus 9 2, which would give you minus 7, and plus 3 would be minus 4, so minus 4 is as the 9. So just like that, all the values of any subtree in this tree would be less than 9, so 9 is the greatest. Oh yeah, and we have to return 9. Okay, so how we'll solve this problem is, we're given a subtree, and what we need to do is we'll go to the leftmost node. So we'll go to minus 2, we'll go to 4, and then when we reach 4's left and right, we'll just return a null, a 0 actually. So 4's left would be a 0, 4 will get a 0 from its right. So we'll keep two variables L and R, which will keep check of these values left and right, and also keep a variable called answer, which will keep check of the answer, what we return. So right now the answer is 0. Okay, now what we'll do is we're going to check L plus R plus root dot data. So what is L plus R plus root dot data? In this case it's 4. So 4, and answer, what would answer be? So answer is going to be the max of the current answer, which is 0, and L plus R plus root dot data. Okay, so that means the A will be updated by 4 in this case. Okay, now once it's updated by 4, we'll return to minus 2's L. So all of these elements have an L and R variable. Okay, so minus 2's L property will now get returned the value L plus R plus root dot data, which is going to be 4. So 4 will be returned. Okay, now we'll check minus 2's R variable, which is right, which is 7. We'll check 7's L and R, which will be 0 over here and 0. Okay, then we'll add them up, and when on adding, we'll check if the value of L plus R plus root dot data is greater than the current value of A. So it is greater than the current value of A. So it is greater than the current value of A. So we'll just update this. 8 is 7. Okay, and what we return back is L plus R plus root dot data. Okay, so we're not returning answer, we'll return L plus R plus root dot data, which is 7 in this case. Now when we add these three up, so 4 minus 2 and 7, okay, what we'll get is 4 minus 2 is going to be 9. Okay, so 4 plus 7 11, and minus 2 is going to be 9. So we'll check if 9 is greater than 7 or not. So it is. We'll update A by 9 like this, and we'll return back L plus R plus root dot data. So what is L plus R plus root dot data? That is 9. So we'll return 9. Okay, now we go to 1's right. So on going to 1's right, we go to 3, and then we go to its right, which is 9, minus 9, and we go to minus 9's left, and we go to minus 9's 0. Okay, now on going to minus 9's 1, left and right, we get 0 and 0, and we check if minus, so on adding them, it will give you minus 9. Okay, L plus R plus root dot data, it's minus 9. So we'll check if minus 9 is greater than 9. Is it greater than 9? Though, since it's not, then we'll not update this, and we'll just return minus 9 over here to 3's left. So it's going to be minus 9 Now we'll go to 3's right property, which will be 2. I will check if it has its left and right, which is not, it doesn't, so we'll just return a 0. On returning 0, we'll check if L plus R plus root dot data is greater than the current 9, so it's not, and we'll just return 2 over here. So we'll return just a 2 over here. Now adding -3, 2 and 3, which is 5, so we'll get a -4. So and then we'll check if -4 is greater than 9 or not. So it's not, and then we'll just return -4. Okay, so it's not, and we'll not update this, and we'll return a -4. So now we'll add -4, 9 and 1. So 9 plus 1 is 10, and 10 minus 4 is 6. Okay, so 6. Now we check if 6 is greater than 9 or not. So it's not, and then we it went through all the nodes in the list, and we'll return A, which is 9, as the greatest value in the subtree. Okay, so yeah, let's solve this out now. So what we'll do here is, okay, let's just write this out first. So I'll just create a list over here, answer and answer, append float of -infinity. Okay, and we'll go to function root, okay, root comma answer, yeah, and return of 0. Okay, now we'll create the function here, def func root comma answer, if not root, return 0. Okay, now we'll create the L property and then the R property. So L will be func of root dot left comma answer, and R be equal to func of root dot right comma answer. Okay, and then here we'll just do a check for the value of answer is greater than answer of 0, and if it is, then we'll just make ENS of 0 equal to L plus R plus root dot data. Okay, and then we'll just return over here L plus R plus root dot data. Okay, so I'm running the code. Yeah, and submitting it. Yeah, it's submitted, guys. So yeah, guys, that's all for today's video. And if you like the video, please do like, share, and subscribe, and I'll see you guys in the next video. Thanks.